All right, let's erase some of the old work. We don't need that anymore. We're done with that problem, and we're moving on to a new problem. When you look at the new problem, though, I find something remarkable about it. And by the way, I'm not opposed to you multiplying this out. And I want to point out this is a fourth degree polynomial. If you really want to exhaust yourself, you're going to find all four roots. But again, I'm going to look for simple guys. And the way I'm going to do that, I'm going to make a substitution. And I'm going to say u is equal to 2x squared plus 3x. This makes it easier for me. I see u squared minus 4u is equal to 45. So now I got a quadratic in u, which will have two roots. What do you get over here? Whoops, I'm going too fast. You're going to get u squared minus 4u minus 45 equals 0. And really the problems are written, sort of nicely. And I'm going to say what? 9 and 5 minus 9 plus 5. Does that work? It sure does. So I'm going to say I know what u is. U could be minus 5 or u could be 9. Now, I would not celebrate too much. What I'm going to do is go back and plug it in now. So I'm going to say if u is 9, this is what I get. 9 equals 2x squared plus 3x. Minus 5 is also equal to 2x squared plus 3x. And these are quadratics, and let's see if we can do it in a simple way. So let's do the first one, which is that 9 business. You get 2x squared plus 3x minus 9. The other one is going to be 0 equals 2x squared plus 3x plus 5. All right? And again, however you want to do it, like if you want to factor it, quadratic formula, completing a square, whatever works for you. I really do mean that. I'm not like saying, oh, you have to do this or that, or this is easy, that's easy. It's your path. That's the easy path to take, by the way. But I'm going to try. So let's put this down. 2x and x. And I'm going to try 5 and 1. And let's see. Would that do it? You get 2x squared, you get 5. But plus, it's just not going to work there. So you might say, I'll try something different. And nothing's going to work there. So I'm going to say, I'm going to go right to the quadratic formula in this one over here. Let me put that down for you. X will equal, and the bottom would be 4, minus 3, plus or minus, it should be relatively simple to write down, 9 minus 4ac. Well, that's going to be, let's see, 4 times 2 is 8, 40. So what do you get over here? X equals minus 3 plus or minus, this is all over 4, by the way, minus 31, the root of minus 31. Let's write that in the proper way, which would be minus 3 plus or minus I root 31 over 4. All right? By the way, before I do the other one, I want to make sure you understand something, that I do put work down here, and I want to point out to you that this answer, whoops, I didn't mean to do that. I know I do that often, but I got to correct myself. This answer should be listed. All right, that's minus 3 plus or minus I root 31 over 4. I also want to claim that some teachers are sticklers for writing these in the A plus or minus BI form. So that would actually be minus 3/4 plus or minus root 31 over 4I. All right, I'm not a stickler for that. Right, I got to do the other one now. And someone says the other one, well, you already got it written down. It's true, but I want to go through it for you. So 0, and you got to give it a try. I'm going to say 2x and x. And that's the beauty of 2x squared. There's really no choice on it. It's got to be 2x and x. And then I'm going to say 3 and 3. And let's see, plus, minus. Let me see if that works. You would get 2x squared. Let's see, 6 minus 3 is 3x. Works beautiful. What do you get over here? X equals minus 3. Or x equals, that would be 2/3. Those answers will also be listed. I want to point out where they are. They're right over here, minus 3. And you know what? I made a mistake. I just see it now. And it's good that I look at a key, because if I make a mistake, you guys are going to make mistakes. And what is it? It's not 2/3, it's 3/2. And I apologize, right over here. You're going to find out when you study, you make mistakes, and then you say, when I get to the exam, I'm not going to do the same mistake twice. All right? If you do make a mistake, though, make it at the end of the problem. The work I put down for you is very similar to the work that I did up on the whiteboard. The work down's a lot neater though, and I do want to encourage that. All right, let me one other point. I know I've been mentioning it probably too often lately, but my name is Ron Bannon. My email address is Bannon, which is B as in boy, the @ symbol, NNON.US. And just one other comment. I'm also surprised by looking at Wells's answer key. They're very sparse. He does list the answers, all right? He does, all right? And he lists it with the complex numbers. Sometimes he does, sometimes he doesn't. I think what he resorts to, if it's really simple to list the complex number, he does. If it's really tough, and I want to point out what I mean by that. If you remember me doing the problem, number 14, getting the simple one was easy, which is this one over here. It's the other ones that were tough to come up with. And we did find them, but he partially found it. He didn't get them all right? He partially found it. And even that, it's improperly written. But that's what he wrote down in his key, all right? All right, thank you.